Hey y'all, in this video lesson, I'm going to teach you how to graph trigonometric functions. So we're going to look at all 6 functions: sine, cosine, tangent, cosecant, secant, and cotangent. For sine, I already have the graph shown here, so it's kind of a little spoiler, but I want to take you to this website to kind of show you where this is coming from. Obviously, anytime you do a graph, you can do a table of values on your own. For trigonometric functions, your x values would be the radians, theta, and then the y values would be the function evaluated at that radian or at that angle. But I want to show you a visual of this so that you can see where this is coming from. So if you click on that link, it's going to take you to a website. And this is just kind of an animation of the sine function being graphed. So I am, just to kind of get you oriented to this, in the center I have a circle, and that's representing the unit circle. And then behind it, we have a coordinate plane. And on that coordinate plane, the x values are the angles measured in radians. And then on the y-axis, we have the y values. So what's happening here is we're going around the unit circle, and you're going to see charted on a flat plane what that looks like. So I'm just going to hit play here. And you can see as it moves around the circle, the sine function is being graphed on the XY coordinate plane. And as it moves, several times around there, we're getting the full picture of sine function. So if you were to go in and check the values of that, sine of pi over 2 is 1. And so you can see on the graph that at pi over 2, it hits the y-axis, or not the axis, but the y value at 1. And you could check all of those and they would check out with our unit circle. So that's what that looks like. And so over here, we can kind of summarize that on our little sticky note. So I just summarized here what I just stated, that theta is on the x-axis and sine of theta is on the y-axis. And it's just the unit circle flattened out on the coordinate plane. We can do the same thing for cosine. We can go to this website and you can see what that looks like plotted out on an XY coordinate plane. I've taken a screenshot here for the sake of time, and you can see that at 0, cosine of 0, if you remember the unit circle, is 1. Because on the unit circle, if you remember, it translated to XY coordinates on the unit circle, and that cosine of 0 is on the x-axis at 1 for the unit circle, so cosine 0 is 1. And then cosine of 60 degrees or pi over 3 is a half, and so on. So you can kind of see some points there. If you wanted to, you could do a little table of values out beside it just to have some reference points as you go back and look at your notes. And over here on the sticky note, you can summarize kind of what I just said. So you can see here, I did a little table of values just for some reference points. And then I also marked on the graph at pi, it hits down at -1, just so that when you're studying, you can go back and quickly see those. All right, so we can do the same thing for tangent. And if you remember for tangent, there were some asymptotes because of the denominator. There was some values that we had to exclude from the domain because it made the denominator 0. So if you want to, you could go ahead and do a little table of values for some reference points here, click on that link, watch the graphic, and make some notes for this graph. So for my table of values here, I used some strategic points because I wanted to get a good picture of what's going on. And you're going to want to do that for all these functions for trig. You want to kind of guide which values you use based on asymptotes. For sine and cosine, there aren't any asymptotes necessarily for x values, so we didn't have to worry about that. We could just pick some values, and we had all values are fair game, no restricted domain. But for tangent, we do have to consider where cosine theta is 0, because where cosine theta is 0, we're going to have those asymptotes. So on this graph, it's those dotted lines that set up boundaries for where we can actually have a graph. And so in my table of values, I put 2 of those boundaries as kind of buffers there. And then I know that my tangent graph is going to be in between those boundaries. And then I went ahead within those, you can pick whatever angles you want to plot your points. But I picked some points that I knew would be easy to graph. So I went with 3 pi over 4 hits at -1, at 0 it's 0, and then pi over 4 it's 1. And that's going to give me this nice, neat, clean curve right here in between my asymptotes. And then that's going to repeat in the same manner throughout the coordinate plane. So that's tangent. And then now I want you to use those same tools to graph cosecant. And remember that cosecant is the reciprocal function of sine. So we need to figure out where sine theta is 0 so that we can set up those boundaries and plot some points. So go ahead and try it, pause it, try it, come back and check your work. All right, so for this one, sine theta is 0 at 0, pi, 2 pi, and so on. So every pi increments, basically. And so I put dotted lines on those points or those lines, x equals 0, x equals pi, and so on, or theta equals. And then I did some points in between there. Again, I picked some points that I knew were going to come out kind of nicely. At pi over 6, it was 2. At pi over 2, it's 1. At 5 pi over 6, it's 2. And those were easy to graph. So you can see here this curve going that way. Then you might have wanted to do a few more points. I stopped there, but you could do a few more points to kind of figure out what's going on the other side of the asymptote. This is going to be basically a reflection down here. If you just plotted points, you can see that. And then this pattern is going to repeat, one down there, one up here, and so on. So that is cosecant. Now let's do the same thing for secant. Pause it, try it, come back. Your graph should look something like this. It is just kind of a sketch. So as long as it's got the similar shape and pattern, we're good. I did table of values over here. I did set it up a little bit differently so that we could kind of see what happens on the left side of an asymptote and what happens on the right side of an asymptote. There's not necessarily one correct way to do a table of values. And if you want to do more table of values, you can. Just pick some values that are going to give you a good idea as to what's going on here. So in the last example, I had just picked values for one little piece. And so for this one, I was thinking it might be better to do 2 pieces to get that better idea for that pattern. And then if we compare cosecant to secant, we can see if we were to look at the graph of cosine follows this kind of wave pattern like that. And sine follows the wave pattern like that. And so they have some shared points there. And they're going to be, since they're inverses, they're going to be a reflection over y equals x. So it makes sense that this one goes through 1 because cosine goes through 1, or I'm sorry, 0, 1. And then this one goes through here because sine does. Anyway, there's a lot of relation there, many relations there. So now let's do cotangent. Pause it, try it, come back. On these, you might be tempted to, when you're plotting your points, draw like a straight line through the points because based on the scale of my graph, it kind of does look like it would be. But if we consider the asymptotes, which for this case, cotangent is either 1 over tangent or cosine over sine. I went with cosine over sine just because I felt like that would be easier for me. So you're looking to see where sine theta is 0. And we know that those asymptotes, those excluded values from the domain are 0, pi, 2 pi, and so on. I should fix that. That continues in the same manner. And so when you have those boundaries, and then you see the 3 dots there. I can show that. Like that, you might be tempted to draw a straight line, but those boundaries, and if you were to plot some more points, Obviously, if you plot more points, you're going to get a much better picture of that curvature there. Right here, there is a slight curvature there, and if you plot more points, you're going to see that. But since I only went with 3 points, it kind of looks like a line. But the boundaries force that to curve down because you're not going to cross those boundaries. They're just going to run alongside very, very close to the boundaries. So again, if you need to plot more points, never be afraid to do that. If you plotted different points than I did and you got the same graph, then you did it perfectly correct. You just pick whichever points you feel comfortable with and you're good to go. So I hope you enjoyed this lesson. That's all I have for graphing trig functions. If you have any questions, please let me know. I'd be happy to help, and I'll see you in the next one.